How big would Earth need to be to make rocket launches into space impossible? The answer depends on physics, not technology. Specifically, it depends on the limits of chemical rockets, powered by chemical energy, the only type of rockets humanity has ever used to reach orbit. On present-day Earth, reaching low Earth orbit requires a speed of about 9.4 kilometers per second or roughly 5.8 miles per second. That's about 30 times faster than a rifle bullet. Rocket engines eject exhaust at around 4.4 kilometers per second or roughly 2.7 miles per second. While that's slower than orbital speed, rockets don't gain all their velocity at once. They accelerate continuously for several minutes, throwing mass backward and getting lighter as fuel burns, allowing them to gradually build up enough speed to stay in orbit. Even on Earth, this is extreme. The Saturn V rocket that carried humans to the Moon stood 110 meters tall, about 360 feet, roughly a 36-story building. It launched with over 2,800 metric tons of fuel, or about 6.2 million pounds. In fact, nearly 90% of a chemical rocket's launch mass is fuel. The astronauts themselves made up less than 0.1% of the total mass. This shows how close we already are to the limits of chemical rockets. Now imagine Earth were twice its current radius. Assuming the planet has roughly the same density, surface gravity would double. Reaching orbit would now require over 13 kilometers per second, or about 8.1 miles per second, roughly 40% more speed than today. Rockets could still launch, but they would be enormous, burn far more fuel, and lift almost nothing. Spaceflight would become rare and heroic rather than routine. At around 3 times Earth's radius, chemical rockets approach a critical threshold. The required orbital speed becomes so high that the amount of fuel needed grows exponentially. Even a rocket made almost entirely of fuel would struggle to carry any useful payload. No amount of clever engineering can overcome this, because the limit is set by the rocket equation itself. Beyond roughly 5 times Earth's radius, the limit becomes absolute. Even in theory, chemical rockets cannot reach orbit. They might lift off briefly, but they would always fall back to the surface. For perspective, Earth's radius is about 6,371 kilometers, or 3,960 miles. A planet 5 times larger would have a circumference of over 200,000 kilometers, or roughly 125,000 miles, about half the distance from Earth to the Moon. By comparison, low Earth orbit sits only about 400 kilometers, or 250 miles, above the surface. That's just a tiny 0.2% of the planet's radius. Another way to see the problem is gravity. On a 5 times larger Earth, surface gravity would be about 5 times stronger than today, roughly 50 meters per second squared, or about 5 times Earth's gravity. A person with a mass of 70 kilograms, about 155 pounds, would feel like they weighed 350 kilograms, or roughly 770 pounds, on that planet. Launching a rocket against that pull becomes physically impossible using chemical fuel alone. This means a rocky planet about 3 to 5 times larger than Earth would be naturally locked away from space. By contrast, Earth sits unusually close to the maximum size where chemical rockets can still reach orbit. Its size isn't just convenient, it's unusually well suited for space exploration.